Okay, so this is section 2.3. It's the last section in chapter 2, and I'd say that it is, sometimes parts of it can be confusing, but if you follow along, take your time, ask questions, you should be in good shape. There are a few parts to it that we have to go through before we get to like the meat of 2.3, and these are kind of like preparatory topics and concepts that we have to go through. So let's start with number 1. First topic starts right there. So they say let U equal this particular set. This U is not just a name of a set like A is. So if you look at A, it is the set consisting of elements L, N, O, P. However, this U is not just a whole other U set. Okay, it's a little bit different. This U over here is known as the universal set. So topic number 1 that we need to address is known as the universal set. All right, and it's denoted with that U, like you see. I do those 2 lines on it so that you kind of know that it's not your standard set. Anytime you see U in our study, well, the only time you see U is in chapter 2, and that represents universal set. Okay, so it's not just a random name of a set like set A, B, C, the stuff we've seen in sections 2.1 and 2.2. It's different. It's different. And so let's define what universal set is. So the universal set represents, essentially, think of like a sandbox or a playpen or your toolbox. It is what you get to use. So the universal set are the elements that you get to use for the problem. Okay, that is why it's so different. So, for example, in this particular universal set, we have K, L, M, O, K through Q, basically, right? K, L, M, N, O, P, and Q. So what you're gonna find is that there's nothing else in your answer that will have anything besides those. Your answer must have something from there, or the sets you create have to have something from there. If you somehow put a 1 in here as the answer, something's off. Okay? So the universal set, like a set of toys or a room full of objects, that's all you get. You walk into the room, this is all we get to work with. If you walk into the sandbox, that's all you get to play with. Okay? So it's so important that you understand the concept of this U, and that it's not a standard set like A. Like A tells you, I want the elements to be L, N, O, P, and sure enough, what is A? It's a subset of the universal set. Now bringing back our topics from 2.2. So you clearly see that any subsets created off of the universal set have the elements and no more than what is in the universal set. Okay? It can have the same or less, but no more. Hence our study of subsets prior to this. Okay, so the universal set consists of the elements that you get to work with in your problem. Okay? So that's a very important topic to start off with. Then they're going to list off some sets. It might be 1 like this problem, it could be 3, 4, whatever number of sets afterwards. But they're going to list off some sets. Now, then they'll have a specific question. Let's take a look at this one. Use the roster method to write the set A complement. So, roster method is another topic you'll need to just know. It's not a big deal. Roster method is just essentially listing the elements separated by commas. That's it. So, for example, this is the roster method. This is the roster method. They want your answer to look like your elements separated by commas. Pretty much almost everything that we saw in sections 2.2, maybe even 2.1, were all given to you in the roster method. There's going to be another method known as a word description. We'll get to that in a moment. But that's all that's saying. So that's another definition, basic definition you have to have to be successful here. If you don't know what roster method is, you might not be able to answer properly. Now, third topic, before we even actually answer the question, but it does relate directly to the question, and I'm going to put 2A and I'm going to put 2B here because we'll come back to this 2B. The third topic here is known as this right here, this little apostrophe. So if we have some set and they put an apostrophe on it, this apostrophe right here is known as the complement. Okay, so that is a very important topic. So we've got universal set, that was a topic. Roster method, that was a topic. Complement is a topic. And really, complement is more an operation. So the first items up to this point were more like just basic definitions. The complement is like a command. It is something you do on the set or not with the set. So what is the complement? The complement is everything not in the given set. So let's say that all they write is a complement. That's all they write. I may not know anything else, but I can at least tell you this, and you should be able to tell me this, is that they're saying, I want everything. My answer to this should be everything that is not in A. You guys following me? All right. So if your answer to A complement has anything that exists in A, you made a mistake. So for example, when I actually go and answer question number 1, if it has an L, N, O, or P, or all of them, I've made a mistake. Your answer better not have anything related to A. Okay, does that make sense? Okay, so A complement means everything not in the given set. It could be a B complement, C complement, N, N, O, whatever it happens to be. You will occasionally see U complement, but no, I don't think we even see that here. But bottom line is that, yeah, you're never going to see U complement because we're not going that deep into it. So how do we deal with a complement? A complement is, yeah, that was kind of fun. Anyways, you accept it. Anyway, so how do we deal with complements? So with complements, what you do is you look at the universal set, you look at the given set, and you know this is what you have to work with in your room, in your sandbox, in your playpen. So your answer does not have this at all, or any of these at all. It will have something here. All the stuff that's not in here, but in here still. Does that make sense? So for example, if I say A complement, L-M-O-P, or L-N-O-P, A consists of L, N, O, and P. So for example, if we're just looking at a visual of this, we won't look at visuals all class long, but a lot of times students, it helps them to learn it with a visual. So if I ask you for everything that is not in A, this is the subset of A. So if I want A complement, I want K, M, and Q. So those would be my answers. That's a lot of talking for a pretty simple problem, but there's a lot of groundwork we have to lay, and things will start moving faster as we go along. Any questions about that at all? Make sense? Okay, so there it is. Hopefully you understand universal set, you understand roster method, you understand A complement, which is the first of 3 major operations that we have on sets, or with sets. All right, so looking at problem number 2, they say let U equal the universal set of this. What is that? In other words, they're describing the set of natural numbers there, aren't they? Because they're starting at 1, 2, 3. This dot, dot, dot means that it goes on forever. Is it okay to have an infinite set as your universal set? Sure, there's nothing wrong with that. Okay, so it's important to note that first. Second thing is A is the set, a finite set, consisting of the natural numbers from 1 through 42, including 1 and 42, obviously. So what is our A complement? What would be our A complement? Well, our A complement is everything not in A. I don't need to draw a sandbox for you with infinite number of numbers in it, hopefully for you to see this. You should be able to see that, okay, if A is this, then everything not in A would start out at 43 and then go on to infinity. And that's how you would type it in. Does that make sense? Any questions about that at all? Okay. So there it is. There's number 2 for you. Let's roll on. Now, here comes the second of the operations. Recall a moment ago, I said that there are 3 major operations that we'll do on a set. The first being a complement. The second being an intersection, and that's what we see right here. So this symbol, this upside down U, is known as an intersection. Okay, so the intersection is what 2 sets have in common. Keyword is in common. So we're not looking at our differences, we're not looking at what all of us have, we're looking at what we have in common. What does that really mean? Well, let's take a look. If we drew a Venn diagram of what's going on here, we have our universal set which boxes it in, right? So the universal set boxes in what we're working on, and then we've got a subset and then another subset. They have elements from within the universal set, and what they have, what they share in common, that is the intersection. So this right here, this spot right here where they overlap, is known as the intersection. Okay? In other words, where if we were looking at you and I are looking at our commonalities, that would also be known as our intersection. Okay? So let's take a look at this problem. So universal set, they have to tell you that because they have to tell you what you've got to work with. Then we have 2 sets now as opposed to 1. We have a set A and a set B. And that would make sense, right? Because if we have an intersection, usually we're going to have 2 sets named. Now, you don't always have to have 2 sets, and we'll see a little special case, but it's not a big deal. But generally, you're going to have 2 additional sets named. And so they're asking for what A intersection B is. These will get more complicated as we go through the section, but they're starting out basic. So what do A and B have in common? If you were to translate this into words, it's asking you what do A and B have in common? What is the intersection between A and B? And so you don't need to draw out a giant picture for this. Just look at A and B, the given sets that they're referencing, and go find out what they have in common. So they have an overlap of 1, an overlap of 2, no 4, no 5, no 6 overlap. So their intersection, what you would put here, is 1, 2. That's it. Questions about that at all? Makes sense? Okay. All right, good. So there you go. There's the intersection. And I'm sure there are a few more exercises that work on the intersection. Let's take a look at this one. No, there aren't. So they jump straight to the third of the operations, and we're going to get plenty of practice with it. We're only on number 4. We're going to get plenty of practice with all of these, and it's going to get a little bit more complicated. Okay? And so let's take a look here. U is known as the union. Okay? So the union, or that U symbol, represents everything from both sets combined. It's what they have in common, what they don't have in common, combined into one set. Now, one quick and very important note with unions is there's no repetition. You get the idea. So there's no repetition. What does that mean? That means that their intersection stuff, the stuff they have in common, you would list it only once. You wouldn't list it twice. So for example, looking at this one, there's the universal set. We're working with the natural numbers 1 through 9. And then we have the subsets A and B. We're looking for the union. Now notice, real quick here, this is why I wrote things very differently. Notice how this U is just a little bit longer and tighter. So, and you just gotta pay attention that you're not confusing these two. It's not a big thing and you shouldn't have too many problems with it. But what this is saying is this is not saying A universal set B. It's not saying that. This is saying tell me what everything from A and everything from B combined into one set with no repetition would be. What is the union between A and B? Versus this, the universal set, which tells you what you're working on. Does that make sense? Okay, so that is why you need to just kind of know the difference between the two. With that said, what is the union between A and B? Everything from A and everything from B combined into one set without repetition. So, in other words, my answer should have all of this. I should see every single one of these elements from A and B down here, but not repeating anything. So that would look like 1, 2, 3. I've got repetition with 3, so I'm not going to write it twice. 4, 5, and 6. What's the picture of what's going on here? Well, the picture of what's going on, if we're looking at the union, is that I take everything they have in common, I don't repeat it, and then I take everything from A, and I take everything from B as well. And so, in other words, I gather everything up and put them all into one set, but I don't write things twice if they happen to have duplicates. Any questions about that? I hope the 3 major concepts in terms of operations make sense. Good? Questions? Okay. All right, let's keep on going. Okay, so let's take a look at this next one. Now, for the first time, we see a combination of topics. Like I said, it's going to get a little bit more tricky. So the stuff we did a moment ago, this is basic groundwork. Let's take a look at the problem. It says, find what goes in the set A complement intersection B complement. If we were to put that in words, everything not in A, everything not in B, what do they have in common? What does everything not in A and everything not in B have in common? That's what we got to figure out. What is the commonality between their, not what's in them, that's the key piece, not what they have. If it was what they have, they currently have, it's an easy question. But now we have a little bit more work we have to do. So, in other words, this is a multi-part problem. What is the first step? First step is go figure out what's in A complement. What's the next step? Go figure out what's in B complement. And of course, the third step, once you know what are not in those sets, is to tie them together with the operation and understanding of what intersection means. Got it? Okay, so let's go do that. So if I wanted to know A complement, I need to know A. So I can't answer this question unless I know first what the definition of complement is. Definition of complement is everything not in the given set. And the second thing I need to know is what's in A. Well, A is 1, 2, 4, 5, so the complement better not have any of those there. I need to reference the universal set so that I know what's not in A, but I don't exceed and add elements that I don't get or have to work with. So 1, 2, I need 3, 4 I've got, 5 I've got, 6 and 7. Did I leave anything out? Double check your work. Easy to make a mistake. So I got 1 and 2. I can't use those. I can use the 3 for the complement. Can't use the 4. Can't use the 5. Don't have the 6 or 7. That's good. So I've got A complement. What else do I need to get? I need to get B complement. What is B complement? Everything not in B. So I don't want 1, 2, and 3 over here. What I do want is 4, 5, 6, and 7. all of my complements have elements from the universal set. They don't have the elements from A and B. I'm good to go. Now, that's not the answer, of course, because what we need to do with that is we need to tie them together using the definition of intersection. And so that definition of intersection tells me that I need to not take everything combined. That's not what I want. That's a union. Intersection, the upside down U, tells me I want what the two sets have in common. Okay? So, what do they have in common? Not 3, not 4, not 5. Looks like 6 and 7. That's it. And that's your answer. Now, in the event that you go and do an intersection and you find that they don't have anything in common, then you can say this, that it's the empty set because you don't have anything. But in this case, we do have something, so you would select that. Okay? Any questions about that at all? Please ask. Questions? Good. Okay, let's keep on going. All right, we got a new problem here. So again, the scenarios, they can play out a lot of different scenarios here. Okay, let's take a look. So we've got A union B complement. A union B complement. And so they have it in parentheses, and then they have the complement. Try to put in words what is going on here. That will really help you kind of form what you need to do to go through all your steps to get to the answer. Form into words what is going on. Well, the first thing you need to do is identify why, or really find a reason or determine the reason why they put A union B in parentheses. They put that in parentheses because you have the prior knowledge that anything in parentheses should happen first. That's why it's in parentheses. They want that. The other reason why it's in parentheses is because if you don't put it in parentheses, that's a totally different problem. This is saying A union with B complement. In other words, what's in A, what's not in B, put it all together. Versus, now let's put this in words, what's everything in A put together? Not that. That's what that's saying. It's saying union everything from A and B, and then I don't want that. You don't want that. Okay? So completely different problems, and so now you understand why we have to have the parentheses there, or why they do. Now if they wanted A union B complement, then they would have done that. So be careful. With that said, what's step 1? Figure out what A union B is. And then step 2, figure out the complement of that. Why didn't I put little steps on the side like I did the previous problem? Because I already know A and B. I know what A and B are, so I don't have to do any extra work in there. Okay, so with that said, let's tie A and B together. Okay, when I tie A and B together, what do I get? Remember, union is everything from both combined without repetition, without duplicates. Okay, so here we go. Let's order it in ascending order. 1, 4, 5. I only count one of them. 6 and 7. I only count one of them. No duplicates. You count it, you just don't write the extras. And so that is the union of A and B. What do I need? I want the complete opposite of that, staying within the parameters of the universal set. So if I want A union B complement, I want basically what? The complement of all of that. So in other words, I want everything that is not in what I just figured out. And I need the universal set to figure those things out. 1, 2, 3, 4, 5, 6, 7. That's it. So 2 and 3, that's all my answers. Unless I made a mistake. Double check my work. So 1, 4, 5, 6, 7. All that's not in there is 2 and 3 given the universal set that 3. Okay, any questions about that at all? Okay. And of course, again, you'll always have an option, or usually have an option. For some reason, it's an empty set. All right. Next. All right. A little bit of a trick question. Draws upon your recollection and understanding of the empty set. And so let's take a look at what's going on in problem number 7. So in 7, it says A union the empty set. A union the empty set. Well, let's put this in a word, shall we? Everything from set A, everything from the empty set. Do they have to write what the empty set is? No, we all know what the empty set is. Empty set is nothing. So everything from the empty set combined into one without repetition. Well, the reality is that's not that big of a deal. Let's take a look. Everything from A is that. Everything from the empty set is that. So the union of the two would be what? It would be everything from A, everything from here, which is nothing, combined without repetition. So in other words, it brings me back to the set A. That's it. Questions about that at all? So if you understand the principles of what we worked on in previous classes, if you understand the principles from the basic definition of each of these operations, then it's not that big of a deal. But again, go slowly, read it through, take your time, and first, I would always try to put in words what's going on. By putting in words what's going on, it helps you kind of break down the process of how you're going to solve it. Okay? All right, next. All right, now the other direction. So, or the other operation. This is saying, what do A and the empty set have in common? Everything from A, everything from the empty set, they're in commonality. Well, we know, again, from the previous problem, that the empty set has nothing in it. If we want the intersection, we are asking for what they have in common. Is that, again, the whole set 4, 5, 6, 7? No, they don't have those in common. What do they have in common? Nothing. In other words, they have the empty set in common. There's nothing that you can list there. If I got 4, 5, 6, 7, I better see something related to that. So this is more so a trick question than the other one, the previous one. So this one is the empty set. Does that make sense? Okay. So again, if you don't know your definitions, it's going to be a struggle. You know your definitions, you know how the operations work, you're going to be in good shape. Okay. All right, next. All right, let's take a look at this one. So they're really having you do a little bit higher level critical thinking to really see, do you know what's going on here? Do you understand how these operations work in and out? Let's take a look at this one. It says A union the universal set. Look at the subtlety there. They are different, like we noted before. So this is saying everything in A, everything in the universal set combined into one without repetition. I don't need to write anything else out. I've got everything I need. I've got A exactly. They didn't ask for A complement. I've got the universal set. So all I need to do is use the operation for union to determine what my answer is going to be. Well, the union is everything from both combined into one. So that's essentially what? The universal set all over again, isn't it? Because if I take everything from both, combine, but don't duplicate it, the universal set covers everybody. So any subset of the universal set, when union with it, is just going to take you back to the universal set. All right? So in other words, you could go list everything out again. I don't think it's going to accept you putting a U in there. I think you actually have to list all the elements out. Unless that's saying it right there. I don't know. We'll see. Nope. Empty set. Okay? Any questions about that? I hope you're starting to feel pretty good about this before we get to the real stuff. So let's take a look at this next one. So 10 is where really things start to take off in terms of a little bit more complexity to these problems. And so as you can see, this is a multi-step problem. Recall when we saw A complement, intersection B complement, that was a multi-step problem. You had to figure out A complement, B complement, and tie them together. Same thing here, except we've got multi steps, right? So recall that I kept saying, try to put in words what happens first, second, third. Try to number what you should do first, second, third, and so on, fourth, fifth, whatever. So I'm going to read through this, and hopefully you, if you're ahead of me, that's fantastic. If you're following with me, follow along as to how my thought process goes when I see something that seems a little bit complicated and difficult. The first thing I notice is that they give me parentheses. So that is like instant telling me this comes first. So this set of parentheses here immediately tells me that this is first. What should I do first? The intersection of A and B. So I need to go figure out, first and foremost, because they give me parentheses, what do A and B in whatever my set here have in common? So that's step one. After I figure that out, they want me to take my answer and union it with B complement. So if you look at this, now we're starting to break it down. Step one, intersection of A and B, what they have in common. Step two, union it with B complement. But it's B complement, meaning that that's not immediately listed, is it? So I am going to, before I can union whatever I get here with that, I have to figure out B complement, don't I? I'm going to have to add a step and figure out what is B complement, because I don't know it right now. I'm going to have to figure that out next before I can tie everything together and finish the problem by unioning that left side here with this right side over here. And that's another skill that you may want to try out. It's kind of trying to look at things from a left-right perspective. Find the thing that separates them and then do that. It doesn't work for every problem, but there will be many that follow that. Okay, let's go do this. Step one, A intersection B. Well, I've got A, I've got B. Notice there's no side work. I need to find their intersection. Their intersection is what they have in common. What do A and B have in common? A, no, D, no, W, and X. That's what they have in common. So I have just completed step number one. But I just need to hold on to this temporarily, right? Because that's not my answer. That's only this part right here. That's this part right there. It's my step one. And if you like labeling steps like this, do it. It's great. There's nothing wrong with being a little bit more detail-oriented so that you limit the mistakes. All right, I've already planned my route. I need to figure out what B complement is. So what's B complement? Well, I'm going to kind of come down here, and I need to figure out what B complement is. What is B complement? Let me do this so it's not so confusing. So B complement is everything not in B, but staying within the parameters of the universal set. B has D, W, X. I don't want any of that, so therefore I want A, H, N, Q, R, that's it, because WX finishes off the universal set. So A, H, N, Q, R, represent my B complement. Now I've just completed step 2, and now I can union everything together from 1 and 2 like they wanted all along. And remember that union is everything from one set and another combined without repeating. Take everything from this part, everything from this part, put them together into one single set, but no duplication. A, alphabetically ideally, H, N, Q, R, W, X. What did I do there? I just took everything here, put them in alphabetical order. If there was any duplicates, which there aren't, I didn't include them. Make sense? Questions about that at all? If for some reason you're struggling a little bit, of course this video will be up online and you can rewatch it to help you prepare. Okay? All right, so I'm gonna give you guys just a moment to work through that previous problem and I'll be right back. So if for some reason you have more questions about it, happy to help you. And then we'll kind of move to the next part, which is more visuals, which I think you guys will do great with. Any questions I can help you guys with? Anything at all? Just raise your hand. See a lot of you guys ahead of me or with me. That's great. Any questions? Oh, question? No. Okay. All right. Let's keep on going. There's a chance, not even a chance. I'm probably going to split this into 2 sections or 2 days. I had forgotten that they changed things up a little bit, and the back half of this section, which deals with truth tables, I believe. Well, we'll just have to see. I just have a feeling that. Might not even have to do that. Well, I take that back. No. I won't have to look at it. Anyways, we're doing okay. Well, I'm not going to break it up into 2 sections. Normally, it's only gone 2-1 through 2-3, and we've been done. It looks like they changed things up, and as a result, what I normally cover with truth tables is now in 2-4. So I might do that. What I'm probably going to do is do that on, I'm going to finish what we're on now, and then our test is probably not on Wednesday. Okay, so if that makes you feel better, great. So, but for sure now, I know for sure it's on Monday. Okay, I was certain it was going to be on Wednesday, but things changed. So does that make sense? There's another section that normally we would end at right now. I thought that they had put that into here, but they didn't. All right, so anyways, okay, it's back. Okay, so let's take a look at 11. If you've done a good job trying to understand what we've done, these pictures kind of are a little easy. And so let's take a look here. So they give you a picture now of what's going on. Well, the great thing is if you understand everything that we did just here, and I drew some pictures for you, this makes your problem so much easier actually. And so let's take a look. A intersection B. Well, that's a really easy question given they show you a picture, isn't it? A intersection B is where A and B combine. Not A and B combine. A and B have a commonality. So their intersection is this common area, and that consists of elements 9, 10, so that would go there. That's all. So instead of listing them out in roster form, they show you a picture and then ask you to put your answer in roster. Okay, that's all. You get the idea. Hopefully that was pretty easy for you, especially given I think we had some tough ones. All right, let's take a look at this next one. This next one says B complement. What's B complement? Everything not in B. Everything not in B. So if this is the set B, we do not want that. We don't want any of this. What we want is everything outside, and be very careful you don't miss the little guys out here. So recall that the universal set is your sandbox. Sometimes the elements that are in subsets do not show up within them, or it doesn't account for every element in the sandbox. This is an example of that. 24 and 27 are not included in either of these subsets, but it is still part of the universal set. So your answer should not just have 2 and 6, it better have 2, 6, 24, and 27 in it. Okay, so that's an easy area to really make a mistake in. Don't make that mistake. Next. All right, let's take a look at this next one. A union B complement. So what is that saying? Well, recall, parentheses, right? So parentheses tell us what we should do first. What should happen first is that you should tie together A and B. Well, tie together, union, would be all of this. That's the union. 3, 6, 7, 11, 14, 16, 21. That's the union. But then it says complement, which means that you don't want any of this. You want everything that's not in that union. So go look around outside of that union. 24, 25 are your answers. Does that make sense? Questions about that at all? Let's keep on going. All right, let's take a look at this one. So in this next problem, they say set A contains 23 elements. Well, maybe we should just draw a picture of this, right? Okay. So A has, in other words, the n of A is 23. What is n? What does that lowercase n represent? Cardinal number. Remember that all the way back 1 or 2 sections ago. When I put n and then the set, I'm saying the number of elements in A is 23. Okay? So just throwing that out there as a refresher. And then B contains 25 elements. So the number of elements, the cardinal number of B, is 25. You guys follow me so far? And you don't have to write it this way per se, but I'm just doing this to help you kind of tie some ideas together. There are 2 elements that are common to sets A and B. In other words, the cardinal number of their intersection is 2. Agreed? So their intersection, A intersection B, there are 2 elements that sit here. Which means what? What does that mean? What does that mean about if they say there are 23 in all of A and there are 25 in all of B? What does that mean when they tell us this very important piece? What does that mean we have to reduce these numbers by? To know what's in there, not in that spot. So if there's 2 items here, and there's a total of 25, that means there have to be what? 23 that are not in their common area. Agreed? Because 23 and what they have in common makes the total of 25. What does that mean about this one? It means I should have only 21 here. Because 21 plus what they have in common makes the total of 23 in that set. You guys following me? So therefore, when they ask you the question, how many elements are in their union? Well, we know the union's what? Everything from A, everything from B, and their commonality without repetition. If you just do 23 plus 25, you do 23 plus 25, what have you just done? You've just added the duplicates in there. Does that make sense? You cannot do that. So 21 plus 2, 2 plus 23 is a total of 46 elements. You put 48, it's going to be wrong. Do not do this. Easy. Somebody's going to do it. But you need to, that's why this problem is so important. Okay? Because it really tests your understanding of no repetition. Okay? All right, so hopefully that makes sense to you. I guess I'll do 15. So I'm going to do 15 over here, just to leave that example up so you can kind of see the slight difference between the two. All right, set A contains 15 letters and 15 numbers. Now I'm not going to use the cardinal number stuff anymore because I just wanted to kind of throw that out there for that set. Set B contains 4 letters and 9 numbers. It doesn't matter what they are. Yes?
You wrote 15 numbers, this is fine.
Oh, thank you. Appreciate it. Thank you for watching. That would have been bad. Keep on going. 3 letters and 0 numbers are common. 3 letters and no numbers are common to those 2 sets. You can kind of see what's about to happen, right? We're going to do what we just did last time. Find the number of elements in set A or set B. Okay, so let's take a look. What is this? First and foremost, let's take a look here. If there's 3 letters here, that means this has to go to 12 letters. That's how many are in this spot. That's how many are in this spot. That's how many are in this spot, because we have to subtract by 3. There is no numbers that they have in common, so that's good. We don't have to do any subtraction. You guys following me? Okay? Now, there's a keyword A or set B. This wording is going to become important. I'm not going to tie it with the operations, but, well, I guess I could do this. I'm not even going to write it extra. The word or is tied to unions. The word and is tied to intersections. It's really important you make that note because we're going to see that a little bit more in this section, and we're going to see that in the next section. Okay? All right? So, with that said, or they're asking for a union. So therefore, we add all these together. 12 plus 3 plus 1, which is 16 letters. 5 plus 0 plus 9 is going to be 14 numbers. And that is our answer. Oh, number of elements. So the total elements, I guess that you would want 30 total elements. So that's actually your answer. So does that make sense, guys? You actually have to go one step further. because they say the number of elements. That means that they don't want you to just tell, okay, what are the letters, what are the numbers? Because if you got 30 right, you probably got the other part right. So you got to add these two together to actually get your answer for that. Make sense? Okay, good? All right, let's keep on going. So what I'm going to do is I'm going to skip 16. And the reason why I'm going to skip 16 is because any problem that looks like this is because the only difference here at 16 is that you have to go and create the sets. So what I'm going to do is I'll at least just show you one, and then you will recognize that once you actually build the setup, or the set and the subsets, the universal set and subsets, it's the same kind of stuff. Okay, so I'm not going to go do more of these. I'm just going to kind of show you the preliminary step to it, and you can finish them on your own time. So this says the universal set is a set consisting of the natural numbers up to but not including 9. So that would look like 1, 2, 3, 4, 5, 6, 7, 8, but not 9 because they don't put an equal sign. The set A is the set of even natural numbers that are less than 9. Less than 9 because you got to stay within your parameters of the universal set. 2, 4, 6, 8. B is a set of odd natural numbers less than 9. 1, 3, 5, 7, but not 9 because you can't include it. C is the set of natural numbers, is all your naturals between 1 and 6. Notice no equal sign, so 2, 3, 4, and 5. Now you've got everything you need. You can go finish that problem, but that's the only thing. Is that anything new? No, because in the previous section you had to do this stuff all by yourself as well. But I just wanted to do that to help you see, hey, this is not that big of a deal. Now you got the sets, you can go work onward with it. Okay? So anyways, there you go. I'm going to skip 17, same concept. 18, same thing. You just have to build a set, and you've done everything after that. 19, same thing, just a little bit more complicated problem. Let's take a look at 20. Okay, so I'll give you like 30 seconds to finish whatever you're on, then we'll look at 20. Somebody give me the time real quick. 34? Perfect. We'll finish on time. All right, take 30 seconds to finish whatever you're on. If you're ahead of me, that's great. And then in a moment, be with me on 20 because it can be a problem that kind of throws people off. Okay, let's take a look. A math tutor, problem 20, working with a small group of students, asked each student when he or she had studied for class the previous weekend. Their responses are shown in the Venn diagram. Use the Venn diagram to list the set of students who studied Saturday in rostered form. So in other words, what do they want to know? Who studied on Saturday? Now, Saturday means that you can have the ones that also studied Sunday. Agreed? Right? So they didn't say only studied Saturday, did they? They said who studied Saturday. They didn't say who studied only Saturday or who only studied Saturday. So studied Saturday is like set A. In other words, it's everything right here. Does that make sense? And so therefore you would list Hannah, Jess, Allen with a comma, and that's all there is to it. For my problem, you might have different names. Okay? So there you go. Again, if you understand what we've done, this is not that big of a deal. In fact, the problems are getting easier. So there you go. Okay, let's take a look at this one. Same type of general question. Let's take a look at this. It says, who studied on Saturday or Sunday? Okay, who studied on Saturday or Sunday? What's the word or tied with? It is tied with union. Okay? So the word or is tied with union, meaning that they want to know who studied on Saturday, who studied on Sunday, combined without repetition. So in other words, Aaron, Sarah, Alan, Zach, Mary, Taylor. Make sense? Okay. All right. Keep on going. Let's take a look at this one. So it says, who studied on Saturday and not Sunday? Okay, so I think that this one is potentially, and let's see if who gets the right answer here. I'll type mine in. I don't think this and right here is meant to imply an intersection. I think the and right here is implied to just say, who studied on Saturday, only Saturday. Okay, so don't think of this like, okay, here's set A, intersection, B complement. Though I wonder if that actually works. Well, it would throw the Don in there too. So it doesn't quite work. So don't treat it like that. Are you guys seeing what I just said? If it doesn't make any sense to you, that's fine. But this is just saying basically who only studied on Saturday. Okay, so don't use that and to connect it to here. It's not what they're looking for. It's kind of misleading wording. So Saturday, not Sunday. Emily. Okay? All right. So hopefully that makes sense to you. Let's keep on going. Let's look at this next one. Number 23. A palindromic number is a natural number whose value does not change if its digits are reversed. Examples of palindromic numbers are 11, 454, 261,162. In other words, if I read it forwards or backwards, it's the same number. Forwards, backwards, same number, bigger number, but still the same principle. Make sense? Okay? So that's what they're saying right here. Use this definition to place 505 in the correct region of the Venn diagram where U is the set of natural numbers. A is the set of palindromic numbers. B is the set of even numbers. So in other words, A right here, this set right here, anything that goes here needs to be palindromic. So anything that goes here needs to be a palindrome. Okay? Anything that goes in B needs to be even. So in other words, what's their overlap? Things that are both palindromes and even. Does that make sense? Okay? So, and then anything that's not there goes out here. Okay? So that's what they're driving at. So let's take a look. So where would 11 go? Let's just put some stuff down. 11 would be a palindrome, palindromic, but it's not even, so 11 would go there. They're not asking you to do this, but I'm doing it so that you can see as an example where everything would generally go. 454, that's palindromic and it's even, so it would go here. 261, 162, that is also one of those. It's palindromic and it's even. So hopefully you get the idea. You guys following me? So the number 505, where does that go? Well, 505 isn't even, so there's no way it can go here, but it is a palindrome, so it goes in region 1. Make sense? Okay, so there you go. Hopefully that makes sense now. It's a little bit tricky problem if you don't see it done. And so I'm not going to do 24, it's the same thing. You can do that on your own. Same thing with 25. 26 is the same thing, all you. And I'm going to do 27 and we'll be done. So some of these problems, I didn't do everything. You guys will have to do a little bit extra on your own time, but maybe it's 20 minutes of extra work. Okay? All right, last problem of the day. And then with that said, I'm not going to talk about how to prep for your test until Wednesday. Okay, so I won't talk about that until we get to Wednesday because we're going to have to do one more section. Okay, So let's take a look at this. Use the Venn diagram to determine n of that. Now you know why I brought up n earlier. Okay, because I knew it was gonna come back eventually at some point. So what are they asking for? What is the cardinal number of whatever this is? In other words, how many, not what. Do you know what I'm talking about? They don't want to know what is there. They don't care about what is in A union B. Do they want us to list dollar sign, percentage sign, triangle, the word 2, word 5, word 7?
No.
No. They want to know how many elements are in that union. And it would be 1, 2, 3, 4, 5, 6 elements. Make sense? Everything that we covered today is potentially going to show up on your quiz. That definitely is going to show up on your quiz. Definitely show up on your test. Okay? So that takes care of 2-3. Good job, guys. We'll see you on Wednesday. No test on Wednesday. Push it off till Monday, and then we'll talk about how to prep.